What is a manifold? Well, I can show you. This is a manifold. Now you might ask, why is a circle a manifold? This is because of two reasons. The first reason is because the circle is flat. What I mean by this is if I have a point on the circle and I start zooming into the region around the point, we see that the region becomes flat. If I were to go to another point on the manifold and start zooming in, we see that the same thing happens again. Exactly like how we perceive the Earth being flat. All manifolds have this flatness property. Let us talk about the second property. All manifolds come with the charts. What are these charts? For the case of a circle, they are straight lines that we can cover the circle with. We can have multiple lines that can overlap with each other when we stick them onto the circle. The important thing is that we have enough of these lines so that the entire circle is covered. If we had a higher dimensional surface, for example a sphere, we would have planes that we stick onto the sphere. Now we have charts, but what are they useful for? Let us place all the charts around the circle, then let us highlight the regions these charts cover on the circle. At the moment, I've made these charts translucent. Let me remove the white circle so that we can focus on the regions. We can see regions where these charts overlap. Now, let me place a point on the circle. This point would appear on the right chart. If we slowly move the point to the region where the right and top chart meet, we see that the point appears on both lines. In this region, we can use any of the two charts to describe the position of the circle. Now, let us move the point around the circle. So far, I've talked about these charts quantitatively. Let's bring numbers into the picture and explicitly define these four charts. First, I will define the circle. It is a set C1 that consists of tuples. The numbers in the tuple both belong to the real numbers, and they satisfy the following relation. We can then define the four charts in the following manner. They take a tuple from the set C1 and map it to a real number. We will call the four charts the right, top, left, and bottom charts. We will explicitly define them in the following manner. The right chart takes a tuple xy and maps it to y. The top chart takes a tuple xy and maps it to x. The left chart takes a tuple xy and maps it to y. Finally, the bottom chart takes a tuple xy and maps it to x. It is important to note that this is not the only way to define charts. Now that we have explicitly defined the charts, let us look at what does it mean. Let us start with a circle. I will place a point on the circle and in the center write out which tuple the position of the point corresponds to. At the moment, the position of the point corresponds to tuple 1, 0. Let us move the point around the circle until we reach back to the starting position. Each position on the circle corresponds to one unique tuple. We can then bring in the charts. As before, I will highlight the regions of the circle that these charts cover. I will place a point on the chart with its current coordinate. Notice that all the other chart values are question marks. This is because the point is not in their region. Now let us move the point around the circle slowly. We see that the y value of the tuple and the value of the chart are always equal. Once we enter the region where the right and top chart meet, we see that the top chart also has a value. It is equal to the x value of the tuple. Let us continue moving the point around the circle. To conclude, a manifold must have two properties. It must be locally flat and it must come with enough charts to cover the entire manifold. Thank you for watching the video.